Okay, this is a video from homework problems sent in regarding regression and correlation and causality. One of the biggest questions I get in probability and statistics is about correlation versus causality. But first I want to talk about the differences between the different terms. Basically, in algebra, pre-algebra, and algebra 1, you were taught how to find the slope of a line. Now, the slope of a line, you can have a line on a graph and it just be purely mathematical. If you have a line on a graph and it's just 2 points and there's really no type of context to those points except for math, then you are calculating the slope, which is basically the steepness of a line. Here's the formula for the slope. If you're given 2 points and there is no context, what do I mean by context? Well, you're not given, these are not widgets produced by a company. It's not gas mileage pertaining to the weight of a car. It's not, there's no context. It's just numbers. And when you have numbers, you're basically calculating just the slope. And there's 4 and 4. And this, we read from left to right, so this is x of 1, this is y sub 1, this is x of 2, this is y sub 2. And we calculate the slope. We plug and chug into this formula, y sub 2 minus y sub 1 over x of 2 minus x of 1, x of 2 being 4, and x of 1 being 2, and we get a slope of positive 1 over 2. So the slope is equal to 1/2. And that means a positive slope. Since this is positive, means it is a slope going left to right, up. Okay? Slope is m. Whenever you see a formula in algebra, y is equal to mx plus b, then we know that this slope that we just calculated is y equal to 1/2 x plus b. So it falls into that slot right before the x. Now that is 100% mathematical. There is no context of any kind. It's just 2 points in the first quadrant. 2, 3 maybe is right here, and 4, 4 is maybe right in there. We've got 2 points. And
priority 1 message coming in on secured channel.
That's my phone, I'm sorry. And it's asking for the slope between those 2 points. Now, a regression line is basically that line that we just talked about right here, but it's drawn in what we call a cluster of points or a scatter plot. Okay? And seeing if there's any tendency. So here is a scatter plot, and it could be prices of movie tickets compared to the cost of the movie being made, or it's just and it looks like a cluster of points. That's why it's called a scatter plot. Now a regression line is taking a line, a mathematical line like this, taking a mathematical line like that and placing it in between these points to where it's called a regression line, and it's called the best fit. Okay? It's the best fit between all 6 of those points.
Priority 1 message coming. Priority 1 message coming in. Priority 1 message coming in on secured channel.
Showing a tendency between those 6 points. Now, that's what a regression line is. Okay, so when you see in this section regression line, correlation coefficient, it's easy to get everything mixed up. The correlation coefficient is the measure of extent to which 2 factors vary together and how well either predicts the other. Such as if you wait in line for a movie, what do people usually do? They used to talk, but now they just browse on their phone. A correlation coefficient can be calculated just like the slope, and it goes from -1 to 0, meaning a negative correlation, and a 0 to 1, meaning a positive correlation. Now, these two can be calculated And this one can also be calculated once you establish the best fit. Okay, now, fortunately, we have two things that can help us with this, okay? Because the correlation coefficient, the correlation coefficient is R. And this is the formula for it. Now, it looks kind of complicated, but if you have found the mean and the standard deviation of a data set in statistics, which we have, you know what this means. This means x minus x bar. We do that to find the variance in the standard deviation. And this is y minus y bar. So you take the y points and you subtract the mean. And I've got an example. And then you add them up. You square them and you add them up. And then you multiply them and square them and add them up. And you take the square root. Now, this formula looks a whole lot more intimidating than it is. And in the next couple of slides, you're going to see where I actually do that. Now, I will tell you, as I tell my students, this I would highly recommend you use the calculator or Excel, because there's no, I think that's the way you spell Excel, I can't remember. There's no reason to go through that tedious math. And it's tedious math, especially if you have a big data set, which means you have 15 or 20 or 100 points. And I would use the technology to help there, okay? Now, what is causality? Now, causality is not usually measured, but it is something that you have to think about. Causality is if event A occurs, when then B will occur. And I always use the example of the Matrix Reloaded, where they go into the French restaurant and the guy says, causality, I drink too much wine, I have to pee. And that's basically what causality is. If something does cause a reaction, okay, such as there's really not anything to do in the movie waiting line except talk or play on your phone. So what we see is now that people play on their phone. So there is a direct correlation there. There is causality there. But there was a study found that said there's a 66% correlation, excuse the misspelled, I meant the typing errors there, between pool drownings and Nicolas Cage films, which I'm not a Nicolas Cage fan, but there's a correlation. But is there causality? Well, some people would say there is, but there's not. Just like there is a 99% correlation between divorce in Maine and the butter consumption in Maine. There's no correlation. There's a correlation. You can put a correlation to any two events, but the causality is, does one event cause the other? There was one study done about ice cream. Ice cream production or ice cream sales go up with murder rates versus murder rates. And the murder rates go up as the ice cream sales go up. Now, a lot of people say, oh my gosh, well, what's the causality? Well, there's no causality between ice cream sales. There's usually another variable involved, which could be the heat. The heat of summer make people come out more, which makes the bad people come out more. The Jasons and the Freddy Kruegers, crazy people, make them come out more. Versus also, the sun comes out, people get out more, eat more ice cream, but people get out more and they get irritated because of the heat. And they have road rage and all this other stuff. Violent behavior is more inclined with stress and heat. So you have other variables involved, but there is no there's a correlation here, but there is no causality. Ice cream does not cause murder, okay? There's no causality there. But you can say temperatures. There is a causality between the correlation of temperatures versus ice cream sales and murder rates. You could say that. So that's the difference between slope, which is a calculated steepness, a regression line, which is that line, that mathematical line placed between data points to get some kind of prediction. And that's what this does. A regression line, and I'll write two more things up here. A regression line helps us to predict. And there's two words, and I'm not going to spell them, but I'm just going to say them because I don't know how to spell one. I mess it up all the time. Interpolation, which is internal, and extrapolation, which is extending or predicting. And I'll show you that in just a minute. So that's a kind of a rundown of those terms. And what happens is students read all these terms and they just get it all mixed up. So I'm going to take a minute and look at an Excel spreadsheet. And I've got two examples done. And I'm going to go through the Excel spreadsheet. Excuse me. I'm going to go through the Excel spreadsheet. And I think this one is the first one. I'm not sure. Yeah, this is a problem. And it basically went ahead and I did this to save time on this. Here's the actual numbers. Now I put these two numbers in right here, the 3.6 and the, let me go to another screen here. Hold on just a second. There we go. These two numbers, I just ignore these two numbers. I put these in here so I could get this extension of the graph right here. So just ignore those numbers as far as the numbers that were actually given to me are these numbers right here. And I went ahead and plotted them. Well, I'm just going to show you, I'm just going to write down a couple of things. You input these on the Excel spreadsheet, and you input these, and then you go to Insert, which is up here. You can see it right there. Insert, and then go pick a graph. Pick which graph you want. And usually I pick the scatter plot, and it'll have a little, and you can hover over it, and it will show you the scatter plot. I'll show it to you in just a second. Let me move this out of the way. Right there. If you were to hit the insert button right here is the scatter plot, right there. Okay? And that's how you do that. Okay? You highlight these two. You highlight these right in here. You highlight those, then you go up here and hit insert, and then you pick the graph that you want. Well, that's what this gives you. Okay? Now, it's only going to give you these points right here. It's going to give you this point and these blue points. That's what it's going to give you. And then, after it gives you those points, if you're an Excel person and you want to use the Excel spreadsheet, then you just click on one of these points and it'll highlight all the points. And you go to insert, let me see which one it is. I can't remember what it is because I just hold on just a second. You click on it. Oops, let me get rid of that. Delete. There. Click on it. Okay. Didn't turn on my mouse, sorry. There. When you see those X's on it, you can right click now and go to add trend line. And when you add the trend line, it's going to add your regression line. All right. Now, basically, this is hard to do unless you run it through the computer or you run it through the calculations. And I just tell students to use that's what the calculator is used for, to do things that are long and tedious, to do them in a quick fashion, and that not to take square root of 25 and to add 2 plus 4. But in this case, I would say that the calculator in the Excel spreadsheet is warranted. Anyway, the calculator goes through the calculation, and it puts, in the Excel spreadsheet, puts this line, that dotted line is your regression line. It's got a positive slope. How do you know that? Right here is your slope. Y is equal to mx plus b. There's m right there. Now, how close it fits to those dots is basically your correlation coefficient. Now, if I explained it to you, the spread of these lines, see, I'm going to take each one of these points and I'm going to extend it to the y-axis. Like that, like that, like that, like that, and like that. And this is what we call the spread of y. And these lines right here are the spread to fit. Spread to fit. Okay? And the correlation coefficient tells you what type of correlation you have, or what type of fit that you have. And it's called R, and that's called the correlation coefficient. R is equal to the correlation coefficient. And in this case, we've got the computer gives us R squared, and we have to take the square root of that 0.3783, and that gives us the correlation coefficient. Okay, now that's what the calculator or the computer will do. I can show you the calculator right quick. Hold on just a second. I need to check something right quick. Let me put this on pause. Okay, now I was going to pull up I thought I lost the calculator. That's what I was trying to find. Let me go back to the calculator. If you go to the calculator, and here's the calculator. Let me erase the board so you can see it better. And hit on. I've already put these in the I already put them in stat plot. You hit second, stat. Oops, I'm in the wrong place. Hold on just a second. I don't know where that came from. Second, quit. Second, quit. Okay, now I'm in the right place. All right, now second, stat. I've never seen that before. I don't know why it's doing that. Oh, I'm hitting second. That's why. I'm sorry. I'm getting myself mixed up. There we go. Stat and hit edit. There is the points that I gave you right there. Okay, on the Excel spreadsheet right there in the blue. Okay, there's the points. And I put them in here. When you hit when you hit stat right here, when you hit stat, it's going to say edit. And you edit right here. Hit the edit button, and it will go directly to this. It'll be blank, and you just fill these in just like you would the Excel spreadsheet. This is your X, and this is your Y. Then after you type it in, you hit stat, and then calculate, and then go down to linear regression, and type in the following. Type in second, L1, comma, second, L2, comma, and then let's go ahead and put in the regression line, and if I can remember correctly, I think it's bars, go to Y variables, go to function, and Y1. I think that's right, and hit enter. Now, write down that information because there's your slope. Now that they teach you y is equal to mx plus b all your algebra years, and then you get to probability and they call it A instead of M. So y is equal to mx plus b or y is equal to ax plus b, but there is the same number that you see here, 0.65. All right? Now, b is your y-intercept, which goes right here, 0.865 there. R squared is 0.3783 right there. And then take the square root of R squared, and that gives you your correlation coefficient, 0.61. So take the square root of this, and R is equal to 0.6151. Now remember, your correlation coefficient goes from 0 to 1, meaning a positive correlation, and then here, negative correlation. From 0 to negative 1 is called a negative correlation. So in this case, 0.6 is right in here. So we have a positive correlation. Now what that means is between these dots in this line is a 0.6 fit, with 0 being right on it and 1 being a larger number. Okay? See, when you have a 0 correlation, it's a horizontal line, and the points, all the points would be like right here, right here, right here, right here, right here, and these would basically cancel each other out. If they cancel each other out, you come out with 0. Okay? If they cancel each other out, you come out with 0 because this one cancels this one. Let me use a ribbon. This cancels this because you're adding them together in the calculations basically. This cancels this one, and this long one cancels that one. And if they cancel out each other, your product or your sum is going to be 0. So therefore, there's no correlation. Okay, so that takes care of this. They cancel each other out in the calculations. Versus this one where they don't cancel each other out, and there is a 0.61. So you could say that better than half, there's a correlation. Now, is there a causality? Well, that's a different question, because this could be ticket sales of a movie and how much each movie costs. This could be cost, the y-axis could be cost, and this could be ticket sales, all right? And as you see, now, is there causality? Not necessarily. It could be something else. It could be what type of movies they are. It could be the weather. It could be whether it's fall versus summer. So you can't say that there's a causality, but you can say there's a correlation. Okay? Now, on the next example, I actually do the calculation on the calculator. And I'm going to pull that problem up. And I just want you to look at it because it can be a little tedious. But the Excel spreadsheet, the reason I do the Excel spreadsheet is not that you have to use the Excel spreadsheet. I do the Excel spreadsheet because it actually can put everything on one sheet where my writing on the board will go all over the place. So let me move up so you can see what the points are. I just made up some points. Okay, there's my points. These points right here, I just made up some. There's my points. That's what's given to you on a problem. So relate this to whatever homework problem you're working on. Here is your points that are given. Usually that's what they give you, and they tell you to find the correlation coefficient and find the slope and see if you can predict something or extrapolate or interpolate, either one. Okay, so there is your point. Now, what you're going to do first? Well, if you want to, you can carry these. You can carry these columns this way if you want to in your notebook or by hand. I did it down here because I didn't want to confuse things, so I put all my X's right here and I put my Y's right here. Remember the formula, and I'll bring the formula in right quick. Well, I can't on this one because I'm doing the transparency. But the formula that we brought up at the beginning of the homework session shows, that you got to subtract the mean from each one of your x's, okay, and do all that. So I'm just going to show you how I did it. First of all, you add up these guys, and you find the mean. Now you've done it in school. You take all the numbers. 1 plus 2 is 3, 6, 10, 15 divided by 5. 15 divided by 5, there's 5 test scores, is 3. And there's my X bar. X bar means the average of the X's. Y bar means the average of the Y's. Okay, so that's these two. That's what you get first. Okay? Add them up. In this case, divide by 5. If there was 10 numbers, you would add them up and divide by 10, just like you did your test scores in any class that you're trying to figure your grade out. Okay? Now, you're going to do just like the variance and the standard deviation, you're going to subtract the mean from each x. So 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3, 5 minus 3. And that's what you get right here. 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3, 5 minus 3. And then you're going to do the same thing with the y's. Okay? 6 minus 4 is 2. 4 minus 4 is 0, and so on. And then you square it. Square the x's, and then square the y's. Add them up. 4 plus 1 is 5, 6, and that's 10. And add these up. And it just so happens that we get 10 for each. Now that is not going to happen all the time. Okay, but that's it. That's what you do. Now, what do I do now? Well, you take the cross product of x minus x bar and y minus y bar, and you multiply them and add them up. All right? What do I mean? Well, the cross product is basically x minus x bar times y minus y bar. So you're going to take this number, -2, and multiply it by 2, and you get -4. -1 times 0 is 0. 0 times 1 is 0. 1 times -1 is -1. And 2 times -2 is -4. And then you add those up, and you get that number right there. And then the formula for R is equal to that -9 over the square root of 10 times the square root of 10. We use this number, and this number. And you plug it in right here. And when you plug those in, that formula I gave you on the first page, you will get -0.9. And that tells us that this correlation is negative. Okay, now that could mean, I don't know, for when the temperature increases or when the temperature decreases, the air conditioner increases or the heat increases, or there could be all kinds of correlation there. I don't know, but a negative, I can't think of one right now. But since this is negative, which means left to right down, and your slope is also negative, 0.9, and this is just a coincidence that the two came out to be the same. That's it. That's your slope and your R. Now, extrapolation and interpretation. Extrapolation is extending. So if I want to extend this line, let me pull this up. Let me erase right quick. And you can always pause the video whenever you need to stop something and write it down. But I'm going to move this up a little bit, if it'll let me. Okay, I'll try it again. Sometimes I have to hit this mouse button twice. There we go. Okay, it's going to let me move it. I don't know why it's doing it like that. I don't know why it's... Oh, there we go. I was hitting the graph on the inside. I didn't know I was hitting that. Let me move it down. There we go. All right, now I'm going to extrapolate. Extrapolate means extend. Just remember, EX means EX. Extrapolate, I think it's EX, extrapolate. Extrapolate means to extend. So I'm going to extend this line to right there. And I'm going to predict that at 6 days, at 6 whatever, someone or something is going to hit around 1, it looks like 1.1 maybe. So at 6, 1.1. And that's called extrapolation. When you extend the line out, I could do it over here too. What's going to happen at 0 days? How many blah, blah, blah at 0 days? Well, it's close to 7. I'd say 6.9. 0, 6.8, or 6.9. Okay, that would be extending, which means extending or extrapolating. I'm extending, I'm predicting. All right, now interpolation is also a predictor, but it's kind of internal. Internal means it's within these n dots right here. Okay, they know what 3 is, they know what 4 is, but what's the prediction with 3.5? So at 3.5 days, or 3.5 hours, or 3.5 whatevers, what is the prediction? And it would be 3.75, maybe 3.5, comma 3.75. And that is internal, meaning that it's between not only these two dots, or these two ends, but it's also between this point right here and this point right here. Inside you're predicting. This is not a valid data point. There is no point right in here or down here. You're giving it this prediction right here. Okay? Now that's the extent of what you're doing. Now whether you want to do it on the Excel spreadsheet, whether you want to do it by hand, which is tedious and time consuming, or if you want to do it with the calculator. Those are the definitions, those are the concepts, and how you do it. There's one other thing I want to cover, and sometimes a book goes into the null hypothesis, and I'm just going to cover a little bit of that, and that's because somebody asked, so I'm going to cover it, if I can ever get there. There. And let's get out of that, and I want to go back to the whiteboard, so I need to go here. And the null hypothesis is just one of those words that sound big, but it's not really all that. It's really simple. And I'll keep hitting this thing twice. There we go. I'm going to go back to the whiteboard. And as I go back to the whiteboard, which is right there, I'm just going to talk about the null hypothesis. The null hypothesis is usually given. But it's usually given in just words. Null hypothesis, like for these type of questions, the null hypothesis would be R is equal to 0. Okay, meaning that the correlation coefficient is equal to 0, meaning there is no what? Correlation. Oops. Meaning that the question may say, given that there is no correlation, find the blah, 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 and tell if the null hypothesis is correct or valid or whatever. Okay, they're giving you that information. So if the null hypothesis is the correlation coefficient is equal to 0, then there's only one other null, the alternative hypothesis. What's the opposite of true? False. What's the opposite of guilty? Not guilty. What's the opposite of, or not the opposite, but what's the complement of 1? 0. What's the complement of yes? No. What's the complement of true? False. What's the complement of guilty? Not guilty. I can't think of any more right now. But so the alternative hypothesis of equal to 0 is R not equal to 0. Oops, that's theta. There we go. Not equal to 0. Okay, so you just put over here the correlation coefficient. If it's equal to a number, then you have proven the null hypothesis and you reject, you hold the alternative hypothesis and you reject the null. Okay, so it's not really that big of a deal. You write down the null hypothesis, which is usually given in the problem, and then if R is equal to 0 is in the problem, or it says there is no correlation coefficient, or it says one of these things, then the alternative would be not equal. If it says that there is a correlation, then the alternative would be equal. So it's just one or the other. And if you come out and if you do the calculations and you come out with R is equal to negative 0.5, sorry, it has to be between negative 1 and positive 1. It has to be between these two numbers, okay? If you come out with R is equal to negative 5, then you reject the null hypothesis, okay? If you come out with R is equal to negative 0.2, reject the null hypothesis. If you come out with R is equal to 0.001, you reject the null hypothesis. But if you get R is equal to 0, then you accept the null hypothesis because R is equal to 0, and that's what the null hypothesis is. Now, if you had the null hypothesis is equal to, if the null hypothesis is equal to, if they say there is a correlation, then R is not equal to 0. So your alternative hypothesis would be R is equal to 0. So if you come out with R is equal to 0, then you reject the null hypothesis. If you come out with a number, then you accept the null hypothesis. So R is equal to 4. R is equal to 1. Then you would accept the null hypothesis. If R is equal to 0, you reject the null hypothesis. And that's all about the null hypothesis, because usually when you're talking about regression and causality and correlation, usually that's the first part of statistics. You usually don't get into the causality the null hypothesis till later. So this may be a kind of an introductory, depending on what the author is doing in latter sections. So I hope that helps.